concept of the flexible display, wherein you don't need a TV anymore. You can just have a plain sheet of screen which can be used for multiple requirements, including able to fold it and adapt it as a flexible display. Who's not surprised by the mobile technology evolving dramatically? How many sensors? You'll be surprised to note that in a smartphone which is fitting our lap, there are close to 30 to 40 sensors which are constantly picking up data and trying to communicate to various other devices and trying to tell where we are located, whether it is GPS or whether the screen needs to be horizontal or vertical, the gyrometer. So all these sensors are adapting in a very big way in the mobile segment, and that's the challenge for the IoT of things when the design becomes small and at the same time complex. All this leads to huge amount of data that needs to be processed, and this is millions and millions of consumer data or key critical data that needs to be addressed, and hence data processing leading to edge computing, high end kind of analytics requirement, even at the concept of looking at predictive maintenance. That's going to be the theme of the future, wherein maintenance, as and when a failure happens, is a thing of the past. It is preventive or predictive maintenance is going to be the norm of the future, because the kind of data that we are gathering, there's a huge amount of artificial intelligence, machine learning, all that can be applied to, wherein you can avert potential disasters well ahead of time just by doing the analytical and aspects of the data that you have gathered. So all these internet of things coming together, the devices coming together, exchanging information, leads to a huge amount of data that needs to be handled effectively. A quick insight as to what 2020 looks like for IoT. You'll be surprised. We are just a few months away from the end of the year, and hopefully, we are going to hit the $4 trillion revenue just in the IoT space. The number of connected people would be close to 4 billion, and 50 trillion gigabytes of data is what is going to be handled, analyzed securely and effectively. It's very, very important to note that this data, all of us are concerned where our personal data is being handled, whether it's a banking transaction or our health data, needs to be secure so that we are effectively using the Internet of Things for the betterment of mankind. It is expected that close to 25 million apps are going to be leveraged. In India itself, we are seeing huge amount of number of apps being created by startups, which is a good sign, and we need to continue to develop that, because it is for the betterment of the mankind that these applications make it user friendly for us, the consumers, to be able to effectively use the Internet of Things. It's expected that 25 billion plus embedded and intelligent systems are going to be connected. And this is just going to happen a few months from now, by the end of the 2020, by the end of the year. So you can imagine the IoT of things getting adapted in a huge way. And now we'll see the challenges that we need to be aware of when we are getting into such a kind of huge adaptation of IoT. We are entering to the age of connected world. It is one world now, one family. We all know about how our Indian tradition talks about Vasudhaiva Kutumbakam, that's world is one family. That's here to happen, right? So we have got each one of us as end users typically using around 7 connected devices. Even when we are sitting in the car and driving in future, or as we are talking, it is already happening that we are connected. In future, the cars will be talking to one another and trying to avoid accidents. So you can imagine the kind of connectivity that's happening in the communication space. Our shopping experience. Who would have imagined that you can go out and shop without your wallet and the crisp currency notes? Everything is now digitized. The kind of automation that's happening in the industrial space is at a very, very fast pace. It's expected to have a 30% annual growth of The machines being connected to one another, talking to one another, very little of human intervention, and only predictive maintenance and management being done through the humans. Even that might gradually fade off. The autonomous cars, we have seen how experiments are being carried out for a driverless vehicle. You've got the flying drone concepts coming in, either delivering consumables or medicines or even carrying men, and how much of drone adaptation is happening in our warfare. That's a huge kind of stimulus for the adaptation of IoT. Not to forget, on the medical electronic space, how much of connectivity is happening, how much of data, the health data, which is very, very critical for each individual, is being exchanged. We have got concepts of remote health monitoring, where in the remotest part of the developing countries, the healthcare is happening, and then the data is being transferred, shared with some of the experts in the cities, and they can remotely talk to them and tell them what kind of medication that is needed. So the connected one world is here to stay. It is being managed, everything is getting connected, and the most important thing is they need to be secure. That's the most critical aspect. The data that's being exchanged, if it is not secured, it can lead to disaster. And one of the biggest responsibilities or the challenges, as you can see from this graph, is the security. Security of the data that is exchanged in amongst the various devices in the IoT space is the topmost criteria for IoT to become effective and user friendly. The complexity of the designs needs to be the next biggest thing as per this survey. That's primarily because you are just connecting. It's plug and play concept. You are bringing in devices developed by multitude of companies and they are expected to work in one go. How many times you have struggled even connecting an HDMI cable to a high definition PlayStation to the TV? They don't work. That's because interoperability has been an issue. So that's going to be much more complex going into the IoT space because of the design complexity, because of the nature of the footprint of the devices being so small and having the ability to do everything that you would have probably done in a computer of a supercomputing capability. The next, of course, challenge is connectivity. You might have a good product, but if it's not working or getting connected to other device effectively, there is no end use enlightenment or happiness when the connectivity goes bad. So connectivity is the next big challenge that needs to be looked into. The technology, like I said, has been evolving dramatically. The adaptation of technology needs to be much more smarter. It has to be cost effective. It has to reach to the common man. That's when the adaptation of the technology becomes successful and the IoT of things can be a huge success. Integration. Gone are the days when one company used to manufacture and design everything. You are picking up a sensor from an OEM, you are bringing in an antenna from another company, and then you've got the chipsets being manufactured by the who is who of the semiconductor space. And all of these are different companies. They need to just come together work. And how is it possible? By effective system integration checks. Last but not the least is the user experience. The end user needs to be very comfortable in the application that's being used. The end application should solve at the given point of time the problem the customer is facing. If they can solve the problem, but if that usability is bad, the adaptation becomes very slack. So all these are some challenges which we need to be aware of, and this needs to be imparted amongst ourselves as faculty in various education teams or research students, but also the students coming out. They need to be aware of what all things they need to keep in mind. So design complexity, which is nothing but ensuring interoperability, connectivity, security, user experience, system integration. So these are some of the high level challenges that an IoT design engineer or IoT company would be looking to address effectively. A company which adapts all this in a seamless manner, in the most efficient way, and more important, in a timely fashion, would be a successful company to live with. Same way, the technology adaptation using IoT, the governments of the day can roll out successful programs only if all these are addressed. So it's not just one element of IoT that needs to be looked into. It's a company's maze of technologies, connectivity, the ability to ensure that the data is not misused. All of these play out into addressing the challenges of the IoT. The other way of looking at it is the 5 Cs. It's pretty easy to look at it, what we just talked about: connectivity, coexistence. That means the technologies needs to be working at the same time. For example, you have the Wi-Fi enabled at the same time NFC enabled. These two are RF technologies, and these chips potentially have to coexist within a few millimeters of one another. You can imagine the noise that can interfere with one another. So, like the saying goes, the noise of yesterday is the signal of today. The signals of the communication devices are well within the noise band of the yesteryears. So, we need to have the intelligence of the right communication techniques, encoding and decoding capabilities, wherein even the signals which are in very, very low noise floor, less than 0 dBm, so to say, will be able to be picked up, decoded, and used effectively. Last but not the least, cybersecurity. It's one of the critical aspects which needs to be looked into in the IoT, particularly in the IoT space, wherein everything, all devices are connected and data being exchanged on their own whenever the need occurs. And last but not the least, the longevity. That means the battery management, the power management becomes very, very critical. There are a lot of technological advancements that is happening. We all know how rare earth materials are being literally ran after from who is who in the industry today, just for ensuring that those can be used for better battery designs. Gone are the days when we were just picking up a mobile phone. The first thing we look at today is how long is the battery life, whether it is 3000 milliamp hour or 4000 milliamp hour. That basically tells you how long the battery will last. That's an important thing. Again, in the charging, wireless charging space, we are getting into wireless. So when the electric vehicles come into play, you will be moving away from wired charging to wireless charging, very similar to how our mobile phones are talking to the base stations as we move in a highway. Even the future generation electric vehicles would be charged as they are moving. So kind of you can see the lot of aspects that is going in into the power management space, and IoT is not left alone in this because that's the biggest challenge. IoT, most of the devices in IoT work in low power, and hence the need to ensure that they can sustain for a long time because the data that they are handling, particularly in critical situations like the Japan earthquake disaster, which literally ruined their nuclear power plant, they were able to look at what's happening through the drone communication and how long they were able to sustain that. Basically meant same thing with the electronic warfare. The drones needs to be in the air for a long duration, remotely controlled, communicating real-time data effectively. The artificial intelligence comes into play because in the warfare situation, the drones should be able to recognize the friend and foe. So these are some of the software challenges that needs to be looked into. So the biggest concern today in IoT is data piracy and compliance. When what we mean by compliance, not only the electronic compliance like the ROHS or EMI EMC within the limits, but also the cybersecurity laws of each and every country needs to be followed. So compliance is one big chunk of the focus area and one of the biggest challenges that the IoT industry should be cognizant of. Let's look at coming into the electronic space. Gone are the days when we had discrete components. We were building the circuit boards. Now everything is system on chip, or what we popularly call it as SoC. So you can imagine millions and millions of uh, gates are being used on a system on chip, which literally duplicates or replaces the traditional circuit board. So you can imagine here the Wi Fi capability is in the same chip. The NFC capability is in the same chip. They are coexisting within a few millimeters. So the challenges of interference needs to be taken care of. So you need to be aware of how the electronics which are used in the IoT of things is going to be much more complex. Small form factor, the wristwatch, probably 5 by 5 maybe the kind of the PCB that's inside the watch within which you got a SoC, system on chip, which is also doing the power management. You name them, you got the entire electronics now brought into the system on chip concept. So basically, the SoC ensures that the system, from whether it is optoelectrical, even RFIC, even the memories, are all brought onto the single chip. And that's a reality as we speak. So we are getting into nanometer kind of semiconductor fabrication, and companies which are working on the semiconductor space on the silicon wafers are cutting through the roof, so to say, in terms of the cutting edge technology. So you need to work in an environment wherein multitudes of signals are working at the same time, potentially interfering with one another, and you should have the intelligence or the smartness in your uh, signal enablement capability or decoding encoding capabilities so as to not interfere with another. Hence, modulation techniques are being used effectively. We have seen 64 QAM kind of signaling being used, or quadrature amplitude modulation, you name them. Each of the modulation techniques have their pros and cons, and the designers are picking up the best technology that is relevant, prevalent, to ensure that the interference is minimized. In spite of that, how often do we not see our TVs flicker when a tube light is switched on? That's basically interference. Maybe the AC connectivity, the grounding, all those plays an important role in the electronics of IoT. And that's much more complex in the IoT space because all these devices are having very small form factor electronics and having multitude of technologies operating at the same time. Coming into the other challenge, while we saw the electronic challenge, wherein EMI, EMC, all that is important, let's look at the extreme other end, the cybersecurity threats. How many times we have seen in the recent past? Probably a few years back, all of us were exposed to the early morning alert that one of the biggest digital entertainment channels of the world had been hacked. That's something very dangerous. And very recently, we saw how the banking systems were hacked. So, when the IoT of things happen, they are very, very susceptible to attacks, whether it is taking control, disrupting services, steal information. We have seen the security agencies of various countries having specialized teams to address these kind of cyber attacks that is happening. You can imagine what happens if an heart monitoring system embedded in a person is being taken control of. It can lead to disaster. We have seen how autonomous cars in the experimental runs were being controlled without the knowledge of the people who are actually using it, and it can cause accidents and lead to disasters. There are false alarms that potentially can occur from the industrial factories, which can lead to anxiety among the people. So you need to be very, very aware of the fact that the cyber security is the most critical and the top most priority in the current situation as IoT adaptation is happening in a huge way. So now let's see all these challenges. How does it lead to you people in the educational institutes? You've got various departments, right? From mechanical, electrical, electronics, information technology, computer science. Um, all of these departments can come together. Ensure that the faculties are well versed in these areas. And the most important thing is give the students who are coming out of these institutes the insights onto where all they can play a role. They can play a pivotal role in the cloud computing. The cybersecurity aspect we just talked about. We can also talk about how routing of information, particularly during disaster. Typically, we have got secondary links which are automatically enabled when the primary link goes away. So those are very, very mission critical requirements. The routers and the gateways that need to be managed in a very smart way. Not the least, last but not the least, the mechanical teams, the IT teams, the electronic teams, you name them, they can actually look at the next generation sensors, because sensors, actuators is all the foot soldiers who are providing the necessary data to the IoT of things. Whether it is the temperature assessment, the lighting control requirement, the alarm in the home automation, and the cybersecurity requirement, everything is enabled by sensors and actuators. So starting from your mechanical engineering teams, how can they look into the aspects of an IoT requirement, the small form factor, very sensitive, and also the electronics that play out, whether it is the health sensors, the altitude sensors, you name them. So, right from the electronics faculty teams to the computer science faculty teams, it is going to be a huge network of students that would be very much involved when they are working on an IoT project. So, I would encourage the educational institutes potentially to look at IoT as a classic case of how an entire educational institute can work together, work as a team with their various faculty members in various departments coming together and enabling an industry, solving an industry problem of IoT. So that I believe is a huge relevance in the coming months and years, wherein each of us in the educational institutes can pick up a potentially problem area in IoT. You can talk to quite a few of the industries. They are willing to work with educational institutes. I will also articulate on that when we summarize this session. It's an important aspect. IoT is a classic example or technological evolution which covers all aspects, right from the sensors to the application layers. So all the faculty and students of various departments in an educational institute can potentially be the team that's going to enable and solve the problems of tomorrow. So it's very important, and hence I thought it's a great way of talking about IoT today and its relevance to the educational institutes and how to ensure that the syllabus are all up to date in adapting the current industry problems. So let's look at a bit more into the granularity. We saw how the discrete components are migrated towards system on chip. That means design complexity is going to be enormous. What it means is you need to verify the design at every stage, be it using actual verification techniques, and before that using simulation like Professor Geeta talked about the other day. When it comes to technology adaptation, Doctor would have talked about how in the drone technology, the technology is very critical. The farther the or the longer duration of the drone, the power management are going to be huge challenges. So you need to validate those designs. Bringing various subcomponents and expecting them to work in one go would be disastrous. So you need to ensure that the system integration happens, and hence you need to test when everything is fine at the system level if there are any edge cases which might cause the whole setup to collapse. Connectivity is very, very important because the IoT devices need to work in multitude of signals. RF communication is part and parcel of IoT of things. So you need to ensure that the signals are not affected. The EMI, EMC artifacts are taken care of. So you can have your educational institutes anechoic chamber to design the RF antenna in a way wherein the interference is minimal. Also, when it comes to the drone technology, it should not be caught by the radars of the enemy. So kind of you need to work on the material science aspect of that as to how can you absorb the signals that are coming from the radars so as to not reflect back to be identified. So, kind of connectivity, the material that is used are all going to be very, very important. All these are being done as we speak at the educational institution level. Security is the biggest challenge, like I said. Code checks and testing, simulation, hacking, ethical hacking, to put it the right way, are very, very important to ensure that your IoT system is covered from all aspects of cybersecurity. Not but not the least, how easy is it for the user to use it? So, usability. So, we have got a new range of careers to start with usability engineers in quite a few of the product development companies. Their focus is how easy will it be for an user to use it. So that's a big way of looking at how we can adapt things. So basically, all this means that you need to have empathy with the end user. Who's the end user? We are the end user. So if we can start looking at our design, verifying the design, ensuring that it is tested from our own perspective as the end user, I think we would have come out with a great product and a great IoT system. So that's an important message for all of us to be looking at this whole concept of the IoT challenges from our sell point of view, that is from we the consumer point of view. Do we like to have disruptions? Do we like to have our very close health related or banking related data to be misused? Certainly no. So that's an important aspect. Please ensure that we are imbibing the need of being empathetical when we are looking at new designs, design verification, validation. If we are satisfied with our own designs from the point of view that it doesn't hurt us as the end users, I think we would have achieved 90% of success. Still, there's going to be 10%, which is a continuous improvement because nothing is perfect. We need to be continuously improving upon. There might be edge cases which might have missed the eyeballs of the experts. So those things needs to be captured and then subjected to in the next rev. So IoT of things is happening in a such a dramatical way that the softwares are getting updated on the fly. That means over the air, the devices are getting the new firmware being checked out. How often do we see our mobile phones alerting us that there is a new software update that's going to happen? So basically, nothing is perfectly designed and sent out. You go, the time to market pressures are so huge that most of the design teams and the companies are taking the risk of sending out the products with almost 90-95% accuracy. Of course, the health related aspects need to be much more verified, validated to be 100% certain, particularly the mission critical requirements. But in general way, the consumer electronic space, 90-95% readiness is considered good to go. So first to market means you have captured the market. That's the market pressure that most of the companies are into. Well, within these pressures, we need to work and ensure that it works effectively. So early verification is an important requirement in any technology, more so in the IoT design verification. I just articulated time to market pressure is a given. Like pandemic situation is a given, we have to learn to live with it. Time to market pressures are a given. The teams within the organizations need to have the balanced set of test plans to meet those time to market pressures. You need to ensure that you're covered not the traditional usage cases, but also edge case. What happens if my health monitoring system is being used in a very, very bad environment like an automotive? Because automotive is considered to be the worst case signal condition environment because of the vibration and the electronics that are being used there. So they need to still work there. So kind of those kind of edge case coverages in the test plans is very, very critical. And do not, some of you or your students can have a alignment towards testing, which is great. But then the thing that we need to capture or let them know is do not miss out any of the tests because some of these are mission critical IoT designs. So full performance test needs to be done. Transaction driven, for example, when you're into the banking system and exchange of information is happening through the IoT device, you need to be cognizant of the fact that you have captured all the edge cases. And all this can be possible when you've got a expert validation engineer, because some of the things he might take a call on, okay, we can live with some of these defects for the time being, let it go to the market, and like I said, over the fly we'll update the firmware and get it resolved. So those kind of expert decision making, at the right decision making, is very important. uh, Design verification is a must, it's a given. You cannot just assume things and believe that everything will work. And of course all this leads to communication across teams. The individual brilliance is a requirement, but the team performance is a must. So hence IoT as a technological adaptation in educational institution, wherein it brings together multitude of faculties, right from computer science to material science to electronics, to electrical and mechanical. All these teams should work as one team. And hence you see more and more stress being given by the industry of today, wherein your individual brilliance is okay, but are you a team player? So working in teams is going to be the most critical aspect which the industry is looking out for from the students coming out, and that's also true in our day to day life. We are not individual brilliant guys. We might be, but we cannot be successful if we are not able to communicate and work as teams. The other thing is system validation, compatibility tests, which I'll cover in the next few slides, are very, very critical, particularly in IoT, because multitude of signals, whether it is Wi-Fi, NFC, ZigBee, Zigbee, you name them, all of these have to work at the same time. That means signal integrity, interference, all those things have to be handled effectively. Even after having done that, even after having done an effectively good design verification validation, you have the challenge of manufacturing. You can have a brilliant product, but if it cannot be manufactured fast and you cannot validate the performance, that's where disaster occurs. So, not just the system design verification validation, but also whether it is manufacturable. Can you adapt the manufacturing flow of a particular industry to the changes that is going to happen? Will it going to be problematic? Will it be taking a long time? All these factors come into play, particularly when we are manufacturing mass production requirements like in the consumer space. Performance validation, how do we ratify that which is a good design or a good product? You need to validate the performance from the simulated data or against a competitive product. So all these are very, very important things, and it's much, much more important in the IoT aspect, because like we discussed, IoT designs are very complex. They need to work in the extreme conditions, sometimes even in the noisy environment, and that's where the designs have to be verified, tested, and there is no leeway to miss out certain tests. How many times we have seen some of the launch vehicle launches getting delayed because of the last minute alerts? So it's very, very important, even though they would have taken care of massive amount of tests, and even a small glitch would probably result in disaster. And imagine some of these IoT devices are mission critical, whether it is for health monitoring and ensuring that the person health is being taken care of, or in disaster relief management, like in the Fukushima nuclear power plant disaster. How much quickly they can able to address that. So these kind of things are very, very important, and the designs what you are working on for the IoT requirements need to be taken through this complete life cycle. So with that, let's go into each one of them. System validation tests. And this is typical of IoT because most of the components are picked up from various companies and brought together. So they have to work seamlessly, effectively, and hence system validation tests are pretty important. And it is observed that approximately 75% of defects are caught at this stage, which is good because you can make those changes, make the corrections, tweak the circuitry, and get going. Because as we all know, once a silicon is rolled out, doing the second and third rollouts is going to be costly, and companies, industries are not in a position to have those kind of silicon rollouts happening regularly. So you need to ensure that the system validation covers almost all the defects. Typically, that is verified using some of the general purpose test instruments like the logic analyzers, which will give you access to the bus signals, let you know whether the ones and zeros are working fine, whether the timing is okay, what happens if the clock rate is variable, what happens to the circuitry if the voltage variation occurs. So they need to work in the worst case signal conditions. You need to have some of the debugging ports like the JTAG and the IO ports to sample out these information at the initial system validation test. You have to ensure that the logic accuracy in the FPGA or real-time logic accuracy is at its best, because as we go into artificial intelligence and machine learning, this becomes very critical. You cannot let go a wrong information or a wrong logic to work for a situation which might lead to disaster. We will test as much as possible to the real life scenario. You would potentially agree with me that okay, I'm making a transmitting a device of an IoT, let us say a camera on the sensor phone, and then I will just look at maybe a simulated image being transmitted. That might work fine. But in a real life situation, if a fast moving object comes in front of the camera, if it is not good enough to capture that movement, it will potentially lead to a disaster. So, testing the IoT setup or the IoT circuitry to as real application scenario as possible is a must. And that's where we see various simulation tools, test equipments with the ability to manipulate the signals so as to emulate real life scenario is being used. The next one is the circuit marginality test. What does it mean? Will your IoT device work in the worst case condition? How sensitive is it to the voltage? Let us say there is an voltage drop, or maybe the battery life of the mobile phone is less than 5%, and naturally the power management circuitry in the mobile phone manages automatically that okay, now the voltage levels probably will have to go down, but your IC works in that situation. So voltage sensitiveness, temperature sensitiveness. This is more important as the consumer products and also the high end products need to work in the extreme conditions. If some of the components are getting heated up, we have now got the concept of on chip sensors, temperature sensors, which automatically alerts that okay, this particular component is at the edge of its performance because of the temperature. Maybe it needs cooling down, maybe it's automatically shut down for some time and then brought up again. Frequency sensitiveness, it is so important whether an Wi-Fi communication is getting hampered by an NFC device being enabled. So kind of all these concepts to be tested, it is called CMV, circuit marginality validation test, and also known in today's world as four corner test, wherein you test at the high voltage, high temperature, low voltage, and if anything fails in any of these corners, then the device cannot be commercially launched. So it's very important that we are aware that not just the design verification, but also from the testing point of view, the system level test, the four corner tests are very critical for us to be aware of when we enable our faculties in the institutes and also the students to be aware of what is required. They can think about various mechanisms how to make this test. We also hear from the industry the burn-in chamber test, which is nothing but the four corner test being done, wherein you change and validate your device works in the extreme temperatures, whether it is in the desert condition or in the high mountain requirements. These needs to work very effectively. So important for us, and also not to forget the depth of the ocean, wherein some of these variables are being used effectively. Signal integrity, this is of course going to be critical because like I said, from the discrete components, we have moved into the system on chip processors, and they work at very high frequencies. And the margins that is available for, between a pass and a fail is so narrow. So you need to ensure that you are testing each and every aspect of the signal integrity requirements. Like I said again and again, it's very important that on a small form factor SoC, you've got the NFC chip, circuitry, you've got the Wi-Fi circuitry, you've got the Bluetooth circuitry. All of them need to be working at the same time without interfering with one another. The crosstalk has to be handled. The glitches, the voltage drops, and other electrical parameters like the impedance mismatch, all of them needs to be taken care of to ensure that the signal integrity is at its best. How many times we have seen that a problem is potentially due to a wrong connector that is being used or a ground not being connected properly. So signal integrity validation test is a critical aspect, particularly in the IoT space. Once you have ensured that all these are working effectively, the next aspect is the manufacturing validation. You might have a great design, but if it cannot be manufactured within a time in volumes, that's going to be bad. How many times we have seen some of the silicon rollouts being delayed because the yield is not good? So, kind of failure in time, low mortality rate are very, very important. Mean time between failures, failure in time. These are some of the industry jargons that we need to be aware of. And what does it mean? How do we address that? Are some of the nuances that we need to keep in mind when we are looking at addressing the customer problems in the IoT space. Performance validation. This is kind of benchmarking, so to say. How do you know that your IoT design is the best? Have you compared with your competing solutions? How do you say your drones have got a better resolution, better maneuverability? That means you need to compare not only from the theoretical performance but also with the competing products. So hence benchmarking becomes very, very important. And during this phase also, in order to be improving on a continuous basis, you might need to change your firmware, your software. You need to probably have a design respin. You can imagine what happens in a product development company. It's not just that we are enjoying the success of a product. A lot goes through the product verification, validation, design, and testing. So it's very important to note that our students who are venturing out of the educational institutes are cognizant of the fact that whether they go in for, let us say, virtual reality or artificial intelligence kind of careers or testing careers, each one of them are very, very important for the success. They are part and parcel of the team. The team needs to be successful, and it's important hence to let the students know that in an IoT space, a classic example, a teamwork is of essence, and each and every individual working on various aspects of the IoT system are equally responsible for the success and failure. Hence, the teamwork. I'm insisting time and again the teamwork is critical because individual brilliance are okay to a certain extent, but if you cannot be a team person, I think it will lead to disaster. Now let's look at what are the typical tools that is used. We have heard yesterday from Professor some of the simulation tools that can be used for design verification. On the electronic side, we know the real-time oscilloscopes or the sampling oscilloscopes can be used for design, debug, and validation. The logic analyzers to look into the logic, the ones and zeros that's happening, the timing variations, whether the glitch is going to cause a disaster, all those things can be looked into by the logic analyzers. Protocol analyzers are an important tool wherein you actually look at layer 2 and above. The kind of data that's being exchanged, whether it is going in the right way, whether a 1 is being transmitted as a 1 or is corrupted due to something to a 0, which can lead to in some mission critical situations lead to disaster. So you need to have protocol analyzers with emulation. That means emulating real life scenarios. Margin test, we'll talk about that. Like the CV test and the ability to deliberately inject errors and see if the IoT system works fine or not. So, timing analysis, logic analysis, protocol analysis are some of the key electronic requirement tools that you need to be cognizant of, and potentially most of the educational institutions have got these equipments already in the labs. For example, here the protocol analyzers with emulation, margin test, and error injection capabilities. Why it is important? You can see here a clock and a data being seen on the screen. And we can test the design by deliberately changing the duty cycle from 50-50 to say 90-10 and see if the design works. And if because of that, the ones and zeros, what you see on the screen there, changes dramatically, is the address and data that is being exchanged is going to be impacted. So kind of you can emulate real life situation scenarios using the protocol analyzers with these kind of capabilities. You can have your own scripts. We'll talk about more of this later. But then these scripts can be if then else condition. If X and Y thing happens, then do this. You can imagine we are now getting into the space of machine learning, artificial intelligence, wherein you can emulate that if a condition A happens, change over to condition C, if not to B. So all these kind of real life scenario conditions can be emulated and ensure that the design works effectively. The margin test capability, whether you are changing your clock duty cycle, setup and hold requirements, the frequency itself changing dramatically, also the voltage. All these can be changed and ensure that the design is effectively working even in the worst case signal condition. So it's important to have some of these instrumentation capabilities being exposed to the students and the faculty so that they are aware that why these equipments are used, where it is used, the practical usability of these in actual industry situations. If they can get exposed to these, they become better engineers or professionals when they get into the industry. All of these would can also be controlled through scripting. So you come across Python scripting, C Sharp, C++, you name them. There's a huge array of software automation capabilities that are required. And more you can see if you can make automation um, close to 100%, that means you have achieved the things what most of the industry gurus are looking at, ensuring that everything is automated effectively. Does it mean humans are not required? Certainly, that's not the case. The humans are very much there for all the requirements at the back end of it, but more and more decision making, you will be looking at the machines taking the call themselves. That means the simulation of the state machines to ensure that all scenarios are captured becomes very, very critical. So, like I said, some of the solutions to addressing the IoT design issues typically look at the electrical parameters using oscilloscopes, real-time oscilloscope to look into the glitches, sampling scope to look into the impedance requirements, the logic analyzers to see whether the state is as expected, whether the timing information between the clock and the data is okay, and of course the protocol analyzer to actually look into the higher layer, layer 2 and above kind of decoding and showing whether it is happening the right way. All this needs to be, of course, like I said, automation is critical and you need to have the ability to have scripting capabilities for that. So, what do Prodigy offer? Now that we have looked at the IoT, what is, what are the challenges, what we typically see in this space. Let's look at the offerings some of the companies like Prodigy are making. We look into the memory interface tools, the sensor interface tools, power management interface testing tools, the RF front end tools. For IoT, all these are a must because in an IoT, we have seen in the last hour or so the nature of the embedded designs, how it is adapted in the industry or the automobile or the mobile, and even in the home automation. So it is very, very important that the educational institute syllabus captures this state of art, current industry needs, the actual challenges faced by the industry, so that the students and the faculty are up to date of what's happening. I'm sure most of you are very much aware of the state of the art recent trends, but this is just a refreshed kind of thing to ensure that this is a continuous process. From the IoT point of view, you can imagine the whole world being interconnected, data being exchanged between machines, and then you need to ensure that everything works as expected. So it's an important aspect that the verification, validation of the design, the testing of the design, and at the system level happens. And that's imbibed by the students right when they're learning, so that when they come out into the industry, they are in a much better situation to handle the things effectively. Uh, Typically, where we are using, we have just talked about it, scopes, logic analyzers with the protocol analyzers with the scripting capability. Um, the challenges in IoT is it's a system on chip, right? You need to be very quick in your verification, validation, and testing. You cannot be doing in sequential way. You need to have the ability to connect multiple interfaces and debug them at a system level so that you get a high level insight if everything works. Traditionally, you have used multiple equipments, maybe an oscilloscope, a logic analyzer, a protocol analyzer. So, what Prodigy have been working towards is to reduce this pain point of using multiple test equipments. We'll talk about that later. So, kind of what it enables is students having exposure to the latest trends in the IoT, actually looking at the data that's being exchanged, whether from the application layer or to the layer 2 level. You can see the actual exchange of information and see where the problems are happening. So, if the educational institutes can have their labs catering to taking care of the current industry real time problems, that would be a great way of enabling students to be industry ready. So let's look at typical debug needs. Like I said, typically timing analysis is used in oscilloscope, logic analysis using a logic analyzer, protocol analysis being done by a protocol analyzer. So these are multiple equipments that are being used. Kind of what Prodigy has come out with is a very, very innovative one box solution, which is a combined protocol analyzer and logic analyzer. So you are now removing two boxes and using this small form factor product, what you see here, uh, taking care of some of the embedded interfaces like UART, SPI, I2C. These are traditionally used in almost every embedded interface, whether it is used in the electronic circuitry of traditional electronics, consumer electronics, industrial automation. These are some of the basic interfaces that are used. So, kind of, we are constantly talking to the industry, our customers, trying to find out what their problems are. We thought this is a great way to ensure that we expose this to the future technocrats coming out from the institutes. This is a single product which combines a protocol analyzer and a logic analyzer. Uh, what we are proposing to the educational institutes, which are captured in one of the slides without much ado on the sales pitch, is we have a two flavors of the educational lab kits which we can ensure we work with your departments and enable you effectively. It's a very small one, weighs around 140 grams. It's a cost effective solution. More importantly, it is not one interface at a time. You can connect multiple interface and look at all of them at the system level perspective at the same time. It's a 10 channel logic analyzer with protocol analysis, timing analysis, and state analysis. So, kind of, you can see where we are coming from, addressing the pain points while the IoT design teams are addressing the end user pain points. We from Prodigy are trying to address the test and measurement pain points. And this is one classic example wherein we are bringing in multiple equipments into a single box. Quick insight as to how we look at it in terms of easy to use graphical interface, whether you want it in the logic analysis mode or a combined logic analysis protocol analyzer mode. When in the timing analysis mode, you can change the sample rate to various factors to find out if there is a glitch and because of which your design is having a problem. You can simultaneously decode and look at various interfaces. So, kind of pretty much trying to solve the customer or the design team's requirement of replacing multiple equipments by a single form factor. The logic analysis gives you an insight as to how the various signals and the states are, what logic are they going in. We can also show the data, the ones and zeros that's being transmitted so that you get a one snapshot view of how it is looking like. A protocol analysis gives you the information of the exchange. Protocols are standard acceptable formats of communication between various interfaces. So I2C interface, UART, SPI, some of the typical interfaces used in the embedded design are used here in an effective way and decoded. A trigger, why it's important. How do you find out a problem has occurred? So it's very easy to look at tons and tons of data and trying to find the needle in the haystack, so to say. But then, if you can know that a particular event happened and you can wait for that to happen and capture it, that's what trigger means. Trigger a situation and then capture it. You can do it on a pattern. Let us say you are looking at a 1010, you enter that, and whenever 1010 occurs on the stream, the equipment is up and running. You can also look at the protocol aware, whether it is on I2C, SPI, or the industrial Ethernet, automotive Ethernet, or the mobile interface solutions. You name them. This small box, what you saw, will be available in various flavors. The first version is for embedded design, ideally suited for the IoT community. So, an important parameter to look out for a combined protocol analyzer and logic analyzer. So kind of makes it very easy for the educational labs. You no need to have multiple equipments because you do both timing analysis, state analysis, and protocol analysis at the same time. You need to capture everything as and when it happens. You cannot use a logic analyzer. You find a problem, then connect a protocol analyzer. The problem would have gone. So it's very important for you to have the ability to look all of them in one go. So what we are proposing to the educational institution is the basic kit, which is this newly introduced logic analyzer, 10 channel logic analyzer, come protocol analyzer with the demo kits. So that would be a good stepping stone or a starting kit. But then from Prodigy point of view, we support various equipments, protocol analyzers, which can emulate, simulate various interfaces to ensure that you are. In fact, we are very proud to say that on the memory side and the sensor side, our solutions have been rated the best in the world. So kind of some of these are evolving as we speak because the technology is changing, the specifications are changing. Prodigy has a very healthy attitude of being part of the standards body. So we define the test procedures. We know what is happening in the next generation technologies. So as test equipment company, we need to be ahead of even the silicon companies, and that's where we come from. The advanced educational kit is more of a complete set of tools that will enable the institutes to be having the state of the art IoT lab setup, wherein your students can not only design, they can also verify, validate, test, and even perform compliance testing, not only for the memory side, whether it is SD, SDAO, eMMC, or UFS, or the sensor side or the mobile side, wherein I3C, SPMI, RFFE, or on the analysis side, UART, SPI, I2C kind of emulators. So you name the interface solution, Prodigy has got a very good portfolio of products, and we believe this advanced educational kit would make the educational institutes state of the art, and we can make a beginning with the basic kit and then build on based on your funding situation and requirements. So kind of what I wanted to capture all this with very little of sales pitch was to look at what IoT is all about, what are the challenges faced by the industries, and how the educational institutes need to adapt the latest technology in their syllabus. It is an evolving process. We need to ensure that our students coming out to the industry are not on the back foot. They need to be aware of what is happening. They need to be confident to take on the challenges that the industry poses. IoT is a classic example because, as we saw, it's a multitude of technologies that are used, and it's important whether from the firmware or the cyber security aspect or to the sensors. The entire educational institute department, starting from the material science department to the computer science, electronics, mechanical, electrical, you name them, all of them need to come together and is a classic case of if the educational institutes start adapting IoT as an important technology focus area, almost the entire college students would be part of this work and would enable them to work as a team. So the whole essence of this session was to ensure that we talk about the current situations that is happening in the IoT space so that we equip students to be industry ready. We are more than welcome to collaborate with you at any point of time. I myself and my colleagues are constantly interacting with quite a few of the educational institutes to ensure that we impart the latest state of the art technologies that we are working on. We are proud to say that some of the big names in the memory space and the mobile space are partners to us, and we're very happy with our solutions. And one of the things Prodigy does very well is customization. So while some of them are standard products, we work with the customization aspects, and we have done a lot of that, and we continue to focus on that. So what we are proposing here is enabling the educational institutes to have the best in class, state of the art lab facilities. I'm sure most of you have got quite a few of them already there, but we are willing to work with you closely, come out with the best in class solution as we evolve the state of the art test solutions from our space. Uh, Ideal for educational institutes to enable the students and the faculty to be aware of the cutting edge embedded design needs. So, with that, thank you very much for your time. I hope this high level interaction was useful, and I'm open for questions. If not, thank you very much, and you can contact us the website and the link.
So there are two questions from the side of the participants. What type of language is used for IoT?
Yeah, that's a brilliant question. Like I said, you can adapt to whatever kind of requirement it is. I think tomorrow's session is on using the Arduino kind of techniques. So that's one way. See, if you're looking at the testing parameters, Python is the current trend that is happening. C sharp, C++, and when you go into the embedded space, the actual logic framing languages. Um, you have got an entire portfolio of languages to choose from, but it is not kind of this one for all purpose. You have to dovetail each of the requirements, how effective the coding techniques are to the current design situations are of most importance.
The next question was, where will we get these IoT components and devices for reliable price?
Yeah, there are multitude of companies, whether it is STs or the Texas Instruments, to name some of the companies. If I am allowed to, you can get even some of these companies are willing to work very closely with the educational institute, send out samples. So I would encourage. You to touch base with us, Prodigy. We can help you out with some of the uh, sources where we contact get these components from, and you can directly talk to them. So most of these institutes, whether it is ST Microwave, Texas Instruments, you name them, they are ready to willing to give you design boards, samples, and ensure that you are up and running.
Thank you, sir. There's another question. What is the tentative cost of implementation of testing labs in college?
We are cognizant of the fact that the funding is a critical aspect. I can give a ballpark number. My colleagues on the from Prodigy sales team can be much more effective in providing the details. But at a rough estimate, it can be as low as 5 lakh, going to multiple of lakhs based on what all you want to equip. For example, our memory solutions are on the high end because as you see some of the mobile phones that are coming out today adapt a technology called UFS, which is the fastest flash memory that is being used. So that's going to be high end equipment, maybe a few lakhs, so to say. Whereas the product which I showcased as an introductory one is probably less than 5 lakhs. So kind of we can work it out from 5 lakhs to multiple of lakhs, and this can be incremental. We understand educational institutes have to balance their budget. particularly for the lab equipments in a very effective way. We are cognizant of that and we can work towards that. But to a rough estimate, 5 lakhs to multiple of lakhs.
Thank you, sir. There's another question. Which modulation scheme is preferred for IoT?
That's again a difficult question to answer simply because each requirement or each design, where it is used, where it is adapted, needs different modulation techniques. If you are into, let us say, a drone which is working in an RF space, which is working in the multiple signal conditions of interference, you adapt the best in class modulation techniques and cost effective. Maybe 64 QAM might be expensive. You have the pros and cons. For every design selection, what you make, or modulation, demodulation technique selection you make, you have the pros and cons. There is nothing like a fits to all. It is how you adapt. You might want to work out on a low cost solution, then you have to adapt those techniques which are cost effective. If you're looking at mission critical, you're not bothered about the cost, of course you go with the cutting edge state of the art techniques. 60 64-bit QAM, 16 QAM, you name them. These are some of the typical electronic modulation techniques that we currently hear about. So kind of it's difficult to answer. You can adapt the best one that fits not only the technology requirements but also the cost requirements.
Thank you, sir. How can we apply machine learning to IoT security? Can you please name some existing algorithm?
I'm not an expert on that, but I'll give a very high level. For example, how many of us in the last few years have been taken aback when we are doing a Google search? Automatically, the relevant topics come into the display, right? So that's the application at the back end trying to see analytically what all websites we have visited and try to project that in the next visit. That's the first basic level of machine learning, if I can put it that way. So I'm not an expert on the programming languages used there, but then the application aspect, it can be enormous. I mean, the other day I was trying to look at a particular requirement for my son's sporting requirements. Automatically, it gave me the history of what all I have done in the last few years. Kind of that's the innovative way of machine learning, if I can put it in a crude way at a very high level. The other way of looking at is the critical machines, whether it is the heart monitoring or in the industry, to switch on and switch off some of the parameters, the power situations, if the fluctuation is going beyond, the algorithm takes note of it. This has to be very simple, very fast communicating interfaces that are used, and then they can switch off and switch on. A classic example I always tend to use is our smartphones. The biggest challenge for us is connecting our smartphones to power up. How many of us in our families have fought to connect the power plug to the smartphone? But now we solve that problem with the wireless charging capacity. But this is near real time. How many times we have seen that the mobile phone is automatically alerting us that there are X number of applications which are draining your battery? That's one way of looking at better power management. So all these are the first steps in machine learning, and the algorithm behind that needs to be cognizant of the fact that you are looking at all designs, how it is working, whether they are optimal, whether they can be brought down. There is no point in trying to send a 8 gigabyte payload when your data is in kilobits. So kind of you need to have the mobile phone algorithm at the back end smartly changing from one technology to the other and adapt it as we move towards 5G. So these are some of the nuances, and I would look at it as the first steps which we've already seen in the machine learning space. And you can just extrapolate that from just close our eyes and see which all footprints this IoT device is going to talk to. We should be in a better position to have those machine learning algorithms embedded so that we can do predictive maintenance. So preventive maintenance is gone. Now it is predictive maintenance. You predict that maybe 4 years from now, this particular product, if it is beyond that life cycle, will potentially be on its edge. So those kind of things would really be required more so in IoT scheme of things and more so in mission critical requirements.
Thank you, sir. What kind of routing algorithms can be used in IoT?
At a very high level, I can state that backup, because I have worked in some situations wherein customers, I mean, this came up like I was articulating earlier when one of the world's biggest digital entertainment TV channels was hacked. And immediately you saw a flurry of activity on disaster management. So you need to have the ability to automatically route to the secondary path. And this is more important in IoT of things. You cannot have a single path communication going in, and if something happens to that, the whole thing collapses. You need to have the mechanism to route the signal in the most optimal way possible. So, on the routing algorithms, you have got on the fly algorithms keeping in tab as to which critical path needs to be communicated. For example, it can shut down all the rudimentary communication, only focus on the mission critical path, give them a secondary path, and get going. This is going to be a challenge, and we are here to see that happen in the current COVID situation. The IT infrastructure is under tremendous stress because all of us are working from home. Kind of data that we are downloading or exchanging is huge. And if something happens over the undersea cable, what is the secondary route? So, starting from there at a very high level insight, we can have optimal algorithms in place. And again, you do not have an exact this fits all. You need to adapt and have the right fit to meet your requirements. The design requirements, this is like dovetailing the solution to the problem. It is not this solution solves all problem. That's not going to be the case. You need to be able to customize your requirements as effectively as possible to meet your design needs, keeping in view not just the technology cost, but also the cost that is involved to maintain that. So it's a big play that is happening. If you ask me, there is no one solution to a problem. You have to come out with the optimal solution that fits your requirement.
There's another question, sir. What area is good for doing research in IoT, and what is the scope of doing research in IoT?
I can go back to that slide very quickly to just let you decide. Right? You can be on the medical space, and maybe this is a better slide. If you are an electronics engineer very much interested in designing hardware, sensors, if you're working on sensors, battery management, then if you're into more into managing the software firmware from the computer science or IT space, like we just talked about, how smartly you can route the communications. And coming to the gizmos that are happening, the cloud management. So it's entirely up to you as to what is interest. I would rather put it this way. Please do not get into a job. Make a career out of what you want to do. That's very important. That means the passion of what you really love to do needs to be what you're doing. If you want to get into a job, there are hundreds of jobs available. But as future technocrats, my earnest request is make a career out of what you're doing. How can you make a career is by being passionate about what you're doing, whether it is cloud computing or how to do cutting edge advanced computing techniques, how to ensure that you've got the backups automatically taken care of in terms of managing the networks, and coming to the rudimentary basic concepts of building sensors. You can imagine the kind of sensing techniques that are being adapted. Even a small movement in a home automation, how do we able to capture a thief coming into the house? How do you differentiate between, for example, in an autonomous car, uh, between an adult and an infant, whether they are running or walking across the street? These are nuances which are the real life challenges that you need to be aware of. So Every aspect of an IoT is worthwhile to be part of as a career, and it is for the individual to take a call on what career they want to make out of it. I would say machine learning, artificial intelligence are some of the futuristic and currently happening trends in the industry. That would be a good thing to have. But then imagine you cannot just be an artificial intelligence geek without knowing the end application. I would earnestly request each and every one of you to be empathical to what you're working on, solving a problem. Whose problem? Not someone else's problem. It is our problem. Would you like to have it half baked? Certainly not. Particularly not so when you're in mission critical situations. So, anything you do, be cognizant of the fact that you are doing it for your own good. Would you accept Medicore products? Certainly not. So, that would be the essence for any one of you to encourage your students to pick up a career out of what they're really interested in.
Thank you, sir. What kind of security protocols can be developed to improve security in IoT?
Honestly, again, I'm not the expert on this space, but at a very high level, let's look at how biometrics is considered a better way of cybersecurity at the initial stage. How many layers of firewalling is needed? How can you avoid people misusing the network? How can you secure your IP protocols? How can you ensure that? So it's a huge array of problem solving situations that you need to be cognizant of. So kind of starts from as simple as your biometric data, maybe which is the best way. Is the fingerprint access the best way, or the eyeball the best way? Starts from there, or your voice command, or your signature, or your facial expression. You see how we are adapting. In some of the smartphones you've got the facial recognition to open the mobile. So kind of you have to adapt to those specific requirements. So it's a huge area to focus on. I'm not the expert to talk about please focus on A, B, or C, but I'm giving you insights at a high level as to potentially there is no one solution to a problem. There are multiple solutions. You need to adapt the best one which fits you.
Thank you, sir. Are we allowed to fly any kind of IoT device which we make in India for testing?
That's a great question. As we see, I can tell you from a few months back experience, almost no aeroplanes after the security disaster that happened at 9/11. You're not supposed to have your smartphones or electronic gadgets switched on in flights. So it's as simple as that. Compliance, I would have put a note in one of the slides. Compliance. Each of the country is adapting, managing their rules and regulations as we speak. It's an evolving process. So each one of us have to meet the compliance needs of not only the electronic requirements but also the rules and regulations of the respective countries. So I don't think there is a firm answer to say yes and no to that. It's evolving. You need to be aware of the rules of the countries you're visiting, whether they allow it or not, whether there are specific standard operating procedures that need to be followed. But just do not fly with any IoT device. You might be in a difficult situation.
Is it
Even
possible?
sorry, before just to add, even as we speak, even the drone flights are being controlled. You cannot just fly a drone. You need to have the license. So you see a lot of laws being changed to ensure that the evolving IoT of things. How many commercial companies are ready to fly and deploy drones for delivery? Has the government of the day given? No, because none of the governments across the world are ready to allow all these kind of things, because there has to be rules and regulations. It cannot come in the way of the flight paths, whether it is commercial or otherwise. You cannot just eavesdrop on your neighbors or your. But then security agencies are using the drones in an effective way in crowd management. So the laws are changing. We need to be aware and follow the laws, the rule of the land, so to say.
Is it possible to control IoT devices from anywhere in the world?
We have seen that practically happen. An autonomous car was controlled remotely from a far off place and crashed. So that's the practical reality. Whether it can be avoided, certainly it can be avoided. That's where the technocrats of the future are going to, or people who are already working on it, or ensuring that not anyone can control a device. But there are smart guys using it the wrong way. So it's always going to be a cat and mouse game. While we have got ethical hackers, we have got the other set who are trying to break the law. So it's an evolving thing that needs to be managed, controlled effectively, and that's a huge area to focus on. More so in IoT of things because you cannot let machines be controlled by someone remotely, leading to disasters. So you need to have the checks and balances. The cybersecurity is one big area. If someone asked me if that was the top billing employment, I would say yes, cybersecurity.
Which edge device is suitable for the development of IoT application?
Which edge device? See, as you saw, IoT is a maze. It can be between a motor control in an industry being talking to another machine trying to slow down the speed based on the load. So that's it's as simple as that to the variables. So what kind of technology we need to adapt is going to be different for different industries. Right away, we have seen the industrial 4.0 adapt even the basic interfaces like Profinet, uh, Profibus, Modbus, which are some of the flavors of Ethernet in the industrial space. And then wireless Ethernet is here to stay. Then you've got technologies like I talked about earlier, NFC being adapted, Zigbee being adapted. It's all not done on an overall basis. It's done on need basis for specific applications. So I'm not too sure if I answered that question, but it's going to be difficult to say which edge technology. It's relevant to what you need to solve a problem.
What kind of algorithm can be used for supporting energy efficiency in IoT?
That's a brilliant question. And those of you interested in the power space, this is a huge challenge. You can make millions of rupees, dollars, ones, whatever the nature of currency, if you can ensure that power efficiency is managed effectively. Let's look at how can we have the smart grid concept taking care automatically, uh, reducing the capacity going to a specific street in a city? Yes, absolutely, that is possible. That's the microgrid concept that's already being implemented. Expand that to the entire city. Can we control the loading? When there is an sporting event happening, how much of energy consumption is happening? If it is not there, what time of the day is better to switch off? So these are various kind of ways to look at it. The basic simple one is like I articulated earlier. On a mobile phone, you are getting alerts saying that X number of apps are draining your battery. Good enough alert to start with, to stop it automatically so that your battery life is enhanced. While the who is who in the industry working on the battery designs technologies are striving to see which is the best material to be used for longevity of batteries. While that is happening at one spectrum in the cutting edge space, we have to manage with what we have got, and there are various avenues to do that, various ways to achieve that. The simple one, like I said, is to manage things. For example, if You are enabling your Wi Fi 24 by 7 on the battery. Is it a smart way? Certainly not. The best way of power management is to enable those circuits when they are needed, not to switch it on forever. So that's the first fundamental step of power management. Then you got new interfaces like system power management interface, which ensures that you can plug and play devices. It doesn't. It works on, for example, the DDR5, the memory, the next generation memory uh, technology is going to work at as low as 1 volt. So, kind of, you are trying to reduce the power consumption. At the same time, you have to manage the devices that are being used. So, the best way to start off with is to look at enable things what is needed. Do not enable everything. That's the concept most of the mobile design companies have adapted. They will not switch on all the circuitries on your mobile phone. You will be asked to switch on your Wi Fi connectivity only if you want to. There's no point in having that on 24 by 7 unless it is mission critical requirement. So kind of we start off from there and then manage the power in an effective way while the scientists are working out which is the best rare earth material to be used for batteries.
Which protocol in application layer is suitable and reliable?
A very difficult question to answer. You have to adapt the protocol which meets the requirement of your needs. A protocol which is at let's say layer 2 can be as simple as an I2C interchip communication or even a basic one like UART universal asynchronous receiver transmitter communication, which is so as we have seen the parallel technologies have moved over and serial technologies have come into play. The speeds have gone up, the latencies have come down, so you need to work within that. And that means an important aspect to talk about is the application layer, which is the best one to use. It's very difficult to pinpoint and say this application layer protocol is the best because that might not work in all situations. Adapt your protocol requirements on the application layers based on the focus area you're working on. A cloud based solution might need a totally different application protocol with redundancy backups in place. So, kind of those things have to be kept in mind. But one thing is here to stay: the technology at the layer 1, layer 2 is dramatically changing from low speeds to very high speeds. The latency is basically the time taken by the processor to process and send out the data, is getting smaller and smaller. It's obvious, for example, in an autonomous car, you have to take split second decisions because that's between life and death. So, kind of autonomous cars are a huge challenge. And how can you communicate from one automobile to another? What kind of application protocol is best suited? The one, without naming any of those protocols, I would say the one which can handle cybersecurity effectively. Period.
There's another question, sir. Should we take awareness on RTOS if we need to work on power management? There are a lot of RTOS available. Where can we start it?
Ah, real-time operating system. What is the need of the hour in an IoT? Let's look at it ourselves. Do we want our laptops to take a few seconds? I'm talking in seconds to power on. The answer is no. We want it to be up and running the moment we switch it on, right? So, kind of, does it mean the bad power management needs to be critical? Absolutely, yes. See how we are making this whole user experience. How many of us believe that the laptops switch on and get going the moment we switch on? You might see the display. That display is buying time because at the back end, there is the mission critical initial data that is being exchanged from a RAM so that it can start and lead to a specific memory location to get going. Management is very important, and the choice of whether it is RTOS, real time operating system, or any of the application protocols is absolutely dependent on whether it meets your design criteria needs. There is no one solution fits all. And that's where the beauty of it in our electronic designs. It's not that one design meets all. It's not one smartphone. There are multitude of smartphones, each having its own pros and cons. Millions of buyers are using it. Same holds good in the design aspect. There is no one design that fits all. You might come out with brilliant ideas, which probably might cost initially, but then would be serving well for the community at large. So you adapt it.
Thank you so much, sir. I take this opportunity to thank Mr. Vasudev for enriching and enlightening us with his knowledge and experience. It was a wonderful session, sir. It was very interesting, informative, and interactive. Thank you for giving us a detailed explanation on this topic. The way you explained us about the current trends, the challenges, and the way to give a solution for every problem, and insisting us upon the importance of teamwork was fascinating. Thank you for accepting our request and giving us your time, sir. I also thank all the participants for actively participating and being a part of this session. I finally thank each and every one who is behind this successful session. Thank you so
Have a
much.
good day. Bye bye.
Thank you, Vasu sir, for accepting our invite. Really, we had a very contentful session today. And I wish to thank Rajata sir and Purushothaman sir for connecting you with us, sir. And we are setting up a IoT lab also, sir. We will be in touch with you.
Thank you, ma'am.
And
Thanks for the opportunity. It was a privilege to interact with the faculty. I am a student, like I said, and all of us are students till we die. So I come from that concept, and hopefully I've been able to share some of my thoughts into this 1.5 hour session. And please feel free to touch base with me if you've got any specifics, and I can learn from you people also. Thank you very much.
thank you so much, sir. Dear participants, thank you all for active participation. Let's meet tomorrow. We are winding the session. Thank you all.
Thank you. Have a good day. Bye bye.